This video will give examples with permutation and combination. A teacher will randomly choose 2 students out of a class of 25 to answer a question. How many ways can she do this? This is a combination because it doesn't matter which order in which she chooses the students. They're both going to be doing the same thing, just answering a question. We have a class of 25 and she's choosing 2. So the number of ways she can do this is 25 factorial over 25 minus 2 factorial over 2 factorial, where all we're doing here is just plugging in our numbers n and r into the formula for a combination. And if we do the math, we'll find that's equal to 300 ways. Now we have the same teacher who is again choosing 2 students, but this time one will ask a question while the other will answer. This means that we have a permutation instead of a combination because the 2 students have different roles, and so you want to differentiate between them. So again, we have 25 total people. We're choosing 2. The formula for permutation is 25 factorial over 25 minus 2 factorial. And if we do the math with that, that ends up being 600. A teacher will randomly choose 1 boy and 1 girl to answer a question from a class of 15 boys and 10 girls. How many ways can she do this? Now, we're going to have to use the fundamental counting principle for this by doing the number of ways she can choose a boy, and we're going to multiply that by the number of ways she can choose a girl. Alright, so the number of ways she can choose a boy is equal to combination 15, 1, or 15 factorial over 15 minus 1 factorial times 1 factorial, which is just 15. And then the number of ways she can choose a girl is combination 10, 1, 10 factorial over 10 minus 1 factorial times 1 factorial, which is 10. So applying our fundamental counting principle, we have the total number of ways she can choose 1 boy and 1 girl is 15 times 10, or 150 ways. A class has 10 freshmen, 20 sophomores, 20 juniors, and 10 seniors. A principal chooses 4 students to be president, vice president, secretary, and treasurer. If there must be 1 student from each grade, how many ways can she do this? So we're going to be using the fundamental counting principle again. We're going to have to multiply the number of ways she can choose freshmen times the number of ways she can choose sophomores times the number of ways she can choose juniors times the number of ways she can choose seniors, and then we have to multiply that by the number of ways she can choose different role rearrangements. So that would be like assigning the freshman the president role versus assigning the senior president role. So just like in our last example, the number of ways she can choose freshmen is 10 combination 1, or just 10. For sophomores, 20, juniors, 20, and seniors, 10. And then the number of ways she can rearrange the roles. There are 4 roles total, so the number of ways to rearrange that is 4 factorial. So we get, as our final answer, 960,000 ways. How many different ways can the letters in Tennessee be rearranged? This is an example of permutation with repetition. We have a permutation because the order in which the letters appear matters. In Tennessee, there are 9 letters. We're choosing all 9 of them to rearrange. Now let's look at the repetition. The E's are repeated 4 times. The N's are repeated 2 times. And the S's are also repeated 2 times. Then nothing else is repeated. So to account for this repetition in our permutation, we will divide by 4 factorial times 2 factorial times 2 factorial. which, if we do the math, comes out to be 3,780 ways.